Hello everyone, I am Bogdan Maheros and this is the Data Storyteller community. If you can hear us or you can watch us, just type anything in the chat on the right hand. So type anything like we can hear or we can watch you, so we can know that everything works fine, that the broadcasting is fine, and technically we can start. There is a latency between the moment we are talking and the moment you can see and hear us. Yeah, I see comments. By the way, subscribe to this channel, the Data Storyteller one. Don't forget to press these like buttons. So this helps the YouTube platform work better. It helps the algorithms find us faster and spread the information that we are sharing with you across the globe. So what is the Data Storyteller? This is the community uniting people working with business intelligence, with data science, big data, cloud, and a lot of other interesting data things. So join us on the VIA community, join us at the YouTube, and you can also find the link to the LinkedIn page in the description of this video. So today we are going to talk about building LLMs, about fine-tuning LLMs, and we have great speakers today. We have Artem Hrachov and Taras Ustyianovych, who have prepared a lot of interesting stuff for you. They spent a lot of time. Everything they are sharing is based on their experience. So if you have a similar experience at your projects, or you joined any training programs, share your experience in the chat, or you can join us as a speaker at our next sessions. So, but today's session is some kind of a workshop of an event, like an intro, how to not do a deep dive maybe, but how to start step by step and how to find yourself in all that area. So, Taras, your turn. The stage is yours. Let's start.
Yes, thank you. Thank you, Bogdan, for your introduction. I hope you can all hear me well. Do you? Okay, I think it was a yes. So, yeah, as it was introduced by Bogdan, the topic today is build your own LLM from scratch, step by step. Let me first introduce myself, my co-speaker. So I am a lead software engineer at EPAM, also a PhD student in computer science, where I work on multimodal data fusion. At EPAM, I coordinate Databricks ML certification, and also I'm a certified machine learning engineer and data scientist on such clouds like Azure, AWS, and obviously Databricks. I'm also willing to introduce another co-speaker, my colleague Artem Hrachov. So please, Artem, say a few words about yourself.
Hello, everybody. I am a junior data scientist at EPAM. I am also a bachelor student at Kyiv Polytechnic, and I have a proficiency in NLP especially.
Yep. Thank you, Artem. Okay, I think we can get started. So here's some agenda what we're going to talk today about. Language models, obviously, also some use cases from technical perspective. And we'll tell you about performance efficient model fine-tuning using such tools like LoRA. And there'll be code execution. About this with more details we'll tell you and show you later. And we'll also think whether we could share our notebooks with you so that you can apply these techniques on your projects or just to have some fun with language models. We actually do not expect you to have advanced level in NLP and data science. And actually, it's enough to have just basic understanding of what is data science and machine learning, what is NLP. You might need to know Python a little bit, like how to execute the code, general syntax, and obviously its willingness to learn and improve, because new knowledge, especially in areas like AI and LLM, arrives every day, and you have to stay tuned and up to date with all of this. So first, I'm going to introduce you to what a language model is. In simple words, it's just a model that predicts what the next word gonna be based on the existing context or set of words. For instance, we have here an example, where are you? And model tries to predict what the next word gonna be based on these three previous words: going, making, doing, and so on and so forth. And seems like going is the most likely one. So that's what the model does. It takes into account existing words or tokens and tries to predict the next one. There are actually a variety of language models and their classifications. We are going to compare what's the difference between a language model and a large language model. I should note that there is also ongoing research on small language models, but they are not that popular at this point of time, so we do not compare them. But speaking about language models versus large language models, obviously a large language model is greater. It's trained on massive data sets with billions of parameters, whether a language model is smaller one. Based on smaller data set, it has limited capacity understanding and generating human-like text, whereas LLM is more generic. It can generate complex text, complicated tasks, and it's as I said, it's more generic usually. Whereas language model, convenient one, is specific in its domain or task, and it performs quite well in a specific area. Large language models, they might be more multilingual, capture various communication styles, languages, contexts with great accuracy. So what are the requirements to train or fine-tune a language model? First, you need to have a powerful compute resource, like hardware with GPUs, TPUs, RAM, and storage. From frameworks perspective, the top leaders are PyTorch, and then I would say goes TensorFlow. And it's also recommended to use Hugging Face transformers like Python library. You might also need NumPy pandas for data handling, but this is something quite minor if we talk about compared to PyTorch or TensorFlow. Yeah, obviously you need a lot of data, and it's recommended to have it high quality. But having more data is sometimes even more important than high quality for language models. You will need to find a balance. From time perspective, it might take multiple days or weeks, depending on variety of factors. And costs. Cost is very crucial. It also depends on a variety of factors. I cannot tell you precisely how much you're going to spend. But for instance, taking into account this article, the cost of training NLP models concise overview. To train BERT on Wikipedia and Book Corpora, a foundational model. Depending on the parameter size, so for instance, a model with 110 million parameters would cost you from $2,500 to $50,000. The more parameters you add, the more it increases the cost. But this is training. We'll tell you what's the difference between training and fine-tuning. Talking about fine-tuning and my personal experience, I used to fine-tune MT5 base model for multitask classification. I did it on Azure with NVIDIA Tesla V100 GPUs, 60 gigabyte of memory. My data set consisted of 300,000 records. And I made 10 full iterations over this 300,000 records. So it took me 8 hours on GPU, and I spent approximately $250. Not that much, to be honest, but it's quite a lot. and if I train it on CPU, it would cost me more, much more, and I would spend more time. And it's not efficient, so GPU is the best choice here. And yeah, but if I changed the model, if my data set increased, the instance type changed, obviously, and probably cloud provider task. So the factors changed. Obviously, the cost would change as well. So, but it's still a good benchmark for you to have an understanding how much it costs to fine-tune a model or to train it from scratch. Yeah. Here you have a comparison how pre-training differs from fine-tuning. So about pre-training, it means you train a foundational model from scratch. Fine-tuning, you make it task specific. For instance, if you want to have a model that does summarization, classification, or translation, this is more fine-tuning. You take an existing pre-trained model and you fine-tune it. So pre-training, you make the model learn general patterns, structures of a language. Whereas for fine-tuning, you make this pre-trained model to do specific task. So as I said, pre-training, you create a foundational model that just understands the language. It does nothing except predicting the next word. Fine-tuning, you adapt your model to work well with specific task or in specific domain. Pre-training is very computationally intensive. So if we go to the next two slides, you'll see the costs are really, really huge. And these costs are for pre-training. This cost is just for fine-tuning. And obviously, fine-tuning is less resource intensive. And majority of cases, like I guarantee you, you will not do pre-training. Most of the cases, you'll do fine-tuning, like adapting existing language model or large language model to your tasks. So here are a few examples, like actually one example, when pre-training should be done and when fine-tuning should be done. For instance, you have a low represented language, like, I don't know, Latin language or Crimean language. And you just, or for instance, you cannot find on Hugging Face a language that is specific for model that is specific for your language. In that case, or communication style. In that case, you need to pre-train a model. Like you collect huge amounts of data, just raw data, unlabeled data, just text data, and you pre-train your model. For fine-tuning, I have already a foundational model and I fine-tune it to answer questions, to summarize text, to classify it. And yeah, that's the main difference. And as it said here, pre-training is self-supervised. Fine-tuning is task-specific. It can be both supervised and unsupervised. Mostly it's supervised. 5 simple steps to build LLM. It seems quite simple, but in fact it's not. But overall, you need to gather and pre-process large data set. Then you select model architecture and you pre-train your model if you need to pre-train. As I said, in most cases, you won't do this. Yeah, you do the training, evaluate model performance, and then you do the fine-tuning to perform classification, summarization, generation, and so on and so forth, and also validate the performance. Yeah, majority of language models, including large language models, are based on the transformers architecture. I will not cover in details the specifics of this transformers architecture, just in few words that it was introduced in 2017 in an article by Google, Attention is all you need. And why they are called transformers? Because they transform input sequence to an output sequence. So transformers architecture is based on an encoder-decoder model. It takes an input, encodes it, generates output, and decodes the output, and returns it to the developer. More on how transformers work, you can learn here. Here is a source on a great article on DataCamp, how transformers work. You could read it. And for the sake of saving this time and spending it on more interesting stuff like code execution, I'm gonna just skip the slides for now. Crucial things you should remember. What are the key input components for your transformer model? So yeah, obviously you have text data and you might have labels. Labels might be like labels, it's the target, what you expect the model to return, what you expect to be the output of the model or your request to it. So text is basically transformed to input IDs and attention mask. Input IDs, they are just usually integers that represent your words, subwords. Attention masks help the model to identify what piece of text, what token is crucial and what is not. So where should more attention be paid to and what we can easily ignore. So like here you can see that on top we have this 101, 7592 and so on and so forth. This is the input IDs. Attention masks are just 1 and 0, 1 and 0 like true false. That we should pay attention to this token and to this one we don't need to. And labels, as I said, the target outputs. So for instance, if you're willing to do text summarization, your input data should be like net text, for instance, news article, and the target, the label should be the summary of the article. And basically you have 2 columns in a database, and this is your training data, and you can use it to train or fine-tune your transformer model. So I think this information should be quite enough for you to have a general understanding of language models. And now you might ask me, where can I start? So the best place to start is Hugging Face. This is a repository of code, models, dataset, tutorials to build a machine learning solution. It has both pre-trained and fine-tuned language models, and not only for language, but also for computer vision, for multimodal data. And you can just go there and search. Yeah, so currently it has 702,000 models more. I'm quite sure I made the screenshot a few days ago. I'm quite sure today there are much more models. And even if you are faced with a challenge or a new task on your project to pre-train or fine-tune a language model, do not rush to start the development. I recommend you going to Hugging Face and searching there probably, and an existing solution might already exist there. And especially if you work with such high resource languages like English, 99%, the challenge, the case you might be faced on your project is already solved on Hugging Face. But it's still, even if it does not, it's still a good place to start and use foundational models from there to do fine-tuning. Okay, yeah, we've asked well-known AI agents to generate jokes about training a language model. Personally, I do not find them quite funny, and it's still an area for improvement for the AI agents. But we have actually a voting set up. So please, Bogdan, share in the chat the link to Menti. The Menti is an interactive platform where to interact with the audience, basically. And yeah, now I'll show you 5 jokes generated by AI agent about training a language model, and you could vote there which one you like the most. So joke number 1, sure, feeding me terabytes of text is a great way to achieve feelings. It's like trying to teach a dog Shakespeare by throwing him a library. Haha, very funny.
By the way, Taras, I'm trying to find the link right now. So I guess you left that somewhere in the Teams chat. So
Yes.
if you can just reply in this local chat again, do you have it somewhere?
Okay, I should put it somewhere again.
Yeah. Oh, I can see it already. Yeah.
Okay.
I'm just sending that right in the chat.
Okay, Cool. So I don't need to do anything. Nothing is required from you.
Yes.
Good. Okay. So this is joke number one. Let's proceed to joke number two. What did one language model said to the other after being trained on legal documents? I object to your inference. So inference, this is the point where you send requests to your models. Joke number three, starting with small models, they said, it will be fun. 20 hours of debugging later, why is my loss function so judgmental? Loss function is the functions that help you determine how well your model performs. Joke number four, me explaining to my friends that training a language model is like teaching a cat to write a novel. Sure, it's possible, but do not expect Shakespeare. Yeah, I agree with this. Do not expect Shakespeare to your model to write like Shakespeare, unless you train your model on Shakespeare novels. Joke number five, training language model. Day one, excited and motivated. Day seven, just praying it doesn't crash again. So I expect you guys to be motivated today and excited. And I do not know how you will feel on day number 7 after this workshop, but I hope you'll still keep your motivation as high as possible.
You can just switch again to the first, second, third, fourth, and the 5. So because I see people are voting, so you can just leave like 10, 15 seconds for every joke, and we can like vote. So and you can see the results on fly.
Oh, really? I don't see them.
I can. I guess everyone can.
What is the top joke at this point?
The first and the fifth.
Wow.
The fifth is the winner. So the link for the vote like the link for voting is right in the chat on the right hand. So you can just click it and be redirected. So that's very interesting to watch how people are voting. The fifth is, I guess, the winner.
I do not recall what AI agent generated each of these jokes. I can recall what AI model generated this joke, but for the other one, I do not know. And we used actually 3 AI agents: GPT-4, GPT 3.5, Claude by Anthropic, and Gemini by Google. I really like the response from Gemini, but seems like people are voting for not for the joke generated by Gemini. Anyway,
I guess here is the human effect. So I mean, people can see the fifth only and are voting for the fifth. So if you switch to the first or to the third, I guess they will grow.
Yeah, let's go back one more time, and then I'll proceed with my slides. And we are quite close to the slides of Artem. Okay, joke number 3, judgmental loss function. Joke number 2, I object to your inference, legal documents. And joke number 1, trying to teach dog achieve feelings by throwing him a library. Yeah. Okay. Let's proceed to the next slide, and then we'll move to Artem's slides. So there is one more thing you should be aware of before and even while working with AI and language models, and this is actually environmental impact. It's carbon footprint of language models. It's really huge, and with increased training data and input parameters, it will increase as well. Most developers, most academic institutions, and even like Google, Facebook, they publish research papers where they also highlight this topic. What is the carbon emission from training a model? And for instance, for the LLAMA Llama model developed by Facebook, so training it consumed 2.6 million kilowatt hours of electricity and emitted approximately 1,000 tons of CO2. I don't know, is it great? Is it a huge amount or not? But for instance, 2.6 million kilowatt hours is a daily consumption of a city with population of less actually, between 1 and 2 millions people, depending on a variety of factors like geographical region, is it Europe, is it US, and other factors. But yeah, so how can you calculate the carbon footprint? Quite easily. You just need to multiply electricity units consumed by the amount of CO2 emitted from producing this particular unit of electricity. So for instance, we have kilowatt hours, and here it's mentioned that per kilowatt hour, it's like 385 grams CO2 per kilowatt hour. And you can just do simple multiplication and you get the carbon footprint. So which means we should actually take care and try to consider this factor as well, because if we don't save our planet, I don't think AI will matter to us that much. And here is just one case I would like to highlight to you. This is the Arctic Sea in September 2022. Red lines is how it was before, how much ice there was before, until 2010 approximately. And here it's how it's now. So I say it, I mean it. We should take care of the planet and use AI responsibly, as well as other tools that simplify our life but still might have impact. Yeah, thank you. I think I'm ready to stop sharing and switching to Artem's presentation. So please, Artem, you are welcome to start.
Yeah, hello everybody. Today I will introduce to you another very efficient and interesting approach to fine-tuning that called parameter efficient fine-tuning. These methods are designed to adapt pre-trained models to new tasks with minimal changes to the original model parameters. On the slide you can see the most famous five PEFT methods, but in the reality there are very huge amount of them. The account is higher than 20 for now, and today I will talk especially about LoRA, that is low rank adaptation, and also show how it works in practical part. So from the beginning, let's compare two approaches: standard model fine-tuning and parameter efficient fine-tuning. In case of standard model fine-tuning, we improve the performance of a pre-trained model on a specific task with ample data and computation, whilst in PEFT we deal with limited data and computation. Also, a standard model fine-tuning requires bigger amount of data, it requires longer training time, and also it consumes larger computational resource. It consumes more computational resources. When PFT methods requires smaller amount of data, it has faster training time and uses fewer computational resources. Also, it is worth to add that the standard approach retrains the entire model, and it can cause catastrophic forgetting of all previous learned results, while PFT methods modifies only a small subset of model parameters. So as a result, it is less prone to overfitting, and in case of standard model fine-tuning, it is more prone to overfitting. Yeah. Next, I'll show how works LoRA. LoRA is a PEFT method that focuses on reducing the number of trainable parameters by decomposing weight updates into low-rank matrices, and it is really particularly effective in maintaining efficiency. On the right side of the slide, you can see how it looks like under the hood in models architecture. On the left side, we have pre-trained weights of our transformer-based model. It can be large language model or any transformer-based model. And on the right side, we have two matrices that describing our weights update of these pre-trained weights, and in the at the output we have the sum of we have learned some new relationships from data with these two matrices. Next, let's talk about LoRa's pros and cons. Firstly, it allows significantly reduce amount of trainable parameters. Also, it allows to maintain model performance, and it has high resource efficiency. When we are talking about LoRa's cons. In general, it can be potential performance loss because we don't fully retrain our and obtain a valid result, because you never know how much experiments you need to do when you are trying to reach your goals. Next, as I have said, it requires fewer resources and less data for training, but it still needs sufficient amount of quality data to obtain valid results, especially in tasks related to text generation, like translation and etc. And here on the slide, you can observe results that were obtained while I was trying to train model to translate from English to Latin, but I chose very small, but there was really small amount of data, only 900 data records for translation. And as we can see here, our model result and ground truth label that should be in the ideal variant. So we can observe that model was able to capture only very basic relationships, but it is not a valid result, and model needs more data and resources. From from my experience, I can say that when we are talking about LoRa, it can achieve similar results like fully fine-tuned model on 300,000 of data. It can achieve this result with only 50,000 of data. So yeah, it is a really powerful tool in some cases. Next, let's talk how LoRa's workflow looks like. First, we need to pre-process our data and especially tokenize it. Next step is to load our base model that was pre-trained or trained previously. Next very crucial step is configuring LoRa model and combine LoRa model with our base model. So we have some PEFT model, and we train this combined model, yeah, like a usual one. So what we need to do is save our results and then use it. Now let's talk about different use cases of language models and especially large language models. First, the most simple use case is text classification. It is a process of assigning predefined categories or labels to text data. The most famous application of this task is spam detections or sentiment analysis of reviews or some product reviews, yeah, etc. Next, very popular task is multitask classification. Where it is a process where more than one variable is predicted. It can be like spam detection and language detection in one model. Yeah. Next is text translation. It involves converting a text from one language to another. Yeah, it can be like localization of content or real-time translation services. And text generation. It involves producing coherent and contextually relevant text based on a given input or prompt. The most popular applications from this task is chatbots and conversational agents like ChatGPT on OpenAI. Yeah. So now we go to practical parts of our meeting. So you can switch to Taras's screen. Yeah.
Okay, yeah. Thank you, Artem. It was actually nice and very appropriate introduction for our audience to understand what we're gonna show them using now through hands-on coding. Yeah, let me share my screen. Share screen. Okay. Let me know. Okay, I can see it. I can see it, so you also should see it. All right, let's get started. I'm gonna show you two cases. First one is multitask text classification. Next one is translation. We'll start with multitask. Actually, I faced it on my project quite recently. So it's about, for instance, I have one message and I want to predict multiple variables for it. It's sentiment, plus I want to make a summary of this text, plus I want to understand whether this text contains some patterns. So basically, I'm willing to perform multiple tasks continuously, simultaneously on the same piece of text. And instead of having three separate models, I have just one, and I use it for three purposes. So we'll do it today on using the MT5 model. MT5 has been introduced by Google. It's quite good, depending on the task you aim to solve, but for text classification, it's quite good. So we import here from transformers the MT5 tokenizer. What else do we need? Trainer callbacks. Okay, we're gonna do some pre-processing using scikit-learn and model split, train test validation. So yeah, let's start. So we import these libraries, then we determine the device. Is it CUDA or on CUDA means GPU or CPU. On Mac OS, you do not have CUDA, you have MPS. Yeah, I'm going to use it in the next tutorial. Here, it does not really matter because my dataset is not that huge. So let's import it, and I'm going to generate a random dataset. Yes, it's random, and the results I'll obtain will not be accurate at all. Do not expect to obtain highly accurate classification results with this tutorial. But if I used a high-quality dataset, there is high likelihood I'll get great results. In the future, once I share with you this notebook, you could actually also use this code, but just replace my dataset, my random dataset, with your existing dataset, and you'll be able to get some good results, I'm quite sure. So let's generate the sample dataset. Here is how it looks. So we have some random text, and we have predicted sentiment, which might be negative, positive, neutral, and attitude. Is it friendly or is it hostile? So that's what I did. Now we're gonna encode our label sentiment plus attitude into numbers, because the models, machine learning models, AI models, they work with numbers. They do not work with text. Yes, you put text as input, but they convert it under the hood into numbers. So I do this conversion. I do train test validation split. You actually, I expect you to be aware of this data science concepts like data set split into train test validation. But just if you don't know, this is required like training. This is what our model sees, and validation. This is how we validate our model during training. And test data set is used after the training on data model has never seen during its life cycle, and yeah, and that way we get quite objective results how well the model performs. So we do this, and we also in this cell we also initialize the tokenizer. So tokenizer does what I told you earlier. It creates input ID plus attention mask for our raw data. So yeah, train data set the same, but just you can see our labels get encoded into numbers. And here is the size. So we have like 115 for training, 6 for validation, 7 for testing. Okay, let's now do the tokenization of our data set. So I'm gonna use the tokenizer, MT5 tokenizer. Here's the max length, so maximum number of tokens per the text it's returned, and I also store the labels, the encoded labels as storage tensors. Okay, let's do this. Trying tokenized inputs, and here how it looks like. Later I'll show you a more well-formatted output, but yeah, overall that's what I got. Train labels, so all nicely encoded and stored. Next, I need to initialize a text dataset PyTorch from PyTorch. It's actually more performance efficient if you use PyTorch dataset as wrapper around your data. The most crucial piece you should focus on is this get item. Because, for instance, I have here train tokenized inputs, and I have train labels separately as 2 separate variables. The purpose of this data set is to have everything stored together, so that I call one variable and I get text number 1 or text number 2 and the corresponding labels. So that's the purpose of text data set. And during training, it will obviously retrieve it. So let's define it and create the data sets. We create this data set for each of the split, train, test, validation. So this is how it looks here. And for instance, I'm interested in this piece of text, sample text number 1, if it wasn't randomly split, and the corresponding labels. So I run this cell, and yeah, that's what I get. I got the input IDs, I got attention ID, attention mask, and it returned me the corresponding labels for my train data set at index 1. Here I define what metrics I shall compute, and metrics are crucial because that's how I can objectively evaluate how the model performs. What I compute here, it's overall accuracy. Like accuracy, it's like, I think you should also be familiar with it, but it's like, is my prediction equal to the actual item, or it's not equal? So I can compute accuracy generally for both metrics, then for sentiment, for attitude, and I also additionally calculate precision recall F1 score, which might give me more insights about how my model performs. Okay, I define this function, and what I do now, I need to have an encoding of So as you know, I converted values to numbers, label values to numbers, and now I want to know what number represents what value. For instance, 0 negative, 1 neutral, and 2 positive. Okay, and I'll pass it actually later. It will be actually crucial later during inference when I want to automatically decode back from numbers to text. Model architecture. This is the most crucial piece. I use MT5 encoder model and MT5 config. This model, so if I go to Hugging Face, will be very quick. You could see there are various methods, models you could use for sequence classification, token classification, question answering, conditional generation. I use, I think this one, encoder model, MT5 encoder model, correct. It has no specific head on top, which means it's suitable for performing any task I would like it to do. So if, for instance, I'm fine-tuning, like why it's so crucial for me to have no head on top of it? Because I need to modify it to predict multiple variables. And if it already has specific head prediction, it means it's already fine-tuned for a specific task, like single task classification or summarization. However, without any head, I can add as much heads as I want. And in this case, I'm going to add 2 heads because I predict 2 variables. So nothing really complex here. To be honest, GPT helped me generate this code. So if you struggle with code generation or documentation, you could also ask GPT to help you. Obviously, the results won't be 100% accurate by GPT or any other AI agent, but still they might guide you to reach the right results. So first, what I do, I initialize original configurations, and then I need to define how many labels, how many values per label I have. So for sentiment, it's 3. For attitude it's 2. And as you can see, I pass the following inputs to my model: model name, sentiment labels, attitude labels. Here are the representation of decoding, labels decoding. What number represents what value? Okay, yeah, here I initialize my model and define a new layer, a new classification layer for each of the tasks. So sentiment classifier and attitude classifier. So what else? I need to modify the forward method. This is actually very crucial. So forward method is where the loss computation is done, and loss is what helps us to evaluate how well our model performs. So usually it's done using the logits. Logits, it's, if you're familiar with logistic regression, it comes from there. So you can just, you have something to reference to. And my model takes as input the input IDs, the attention mask, and also later on, I need somehow to compute the loss, and obviously I specify the labels as well. So I use a sentiment classifier, attitude classifier, and I specify this encoded output by the model to make the prediction. So I use one encoded output and get 2 predictions for 2 variables. And then here is where I compute the loss. First, I compute loss for sentiment, for attitude, and then I just combine them and divide by 2. I get an average. But for instance, you have 3 variables you are willing to predict, and you do classification task. You can assign a specific weight to each of these variables. For instance, for loss is more, sentiment is more important to me, therefore I'll assign a weight. 0.7, and attitude is less important. I assign a weight 0.3, and then I just combine them, and I still get my loss, but a model will more focus on improving the sentiment, because it's more important to me. It has higher weight than attitude, and the same way you can modify it here. So okay, have I? No, I don't execute it. Okay, it's done. So now I'm ready to initialize my model. I specify the model name MT5 small. Yeah, actually, both model size, there is also base and there is large, and it applies not just to MT5 but also to other models like XLM Roberta, BERT, and other architectures. Okay, let's run it. I transfer my model to the corresponding device. I think it's CPU here. Yeah, it's CPU here. Okay, and I create directories for the output. Next thing is training arguments. That's where I specify how long and what are the hyperparameters my model should train on. This is from the Hugging Face library, Hugging Face Transformers library. And it's also sort of a wrapper, which helps you to perform model training more efficiently. It's not necessarily to use these training arguments. You can do just conventional for loop and calculate the, all this inside this for loop, but this is more efficient, obviously. So I'll specify some hyperparameters and yeah, define it. And here I'm gonna start the model training. I specify train test, validation set, metrics to compute, the tokenizer, and this training arguments here. Okay, let's start the training. I don't know how much time it's gonna take. In the meanwhile, I'm gonna check whether there are some questions. Quite quick. Yeah, so we already have 5 epochs covered. No, not epochs. These are not, they're just iterations. We have already 4 epochs covered. So as you can see, for each of the epoch, we get the validation loss, what is the accuracy, has it improved or not. The dataset is completely random, so we do not expect any significant result here. This is just for the sake of for showing the concept. And since the dataset is quite small, the training went very quickly, plus the text is not large at all. So what we can see, validation loss has decreased, surprisingly. Accuracy has not improved, except for sentiment. For attitude, it got only worse. And yeah, we have some other cool metrics like a fun precision and recall. And we see here what is the final training output. Okay, I'm gonna save my model. Let's call it sample multitask classification. Okay, model is saved. Here I can see the final model architecture. And if I check the last layers, this is the layers we added. And input features, so this is the input vector it takes with size 512. And I get 3 features for sentiment, 2 features for attitude. And yeah, so that's what we added, what we modified. Model to device, so in that way I make it also on CPU, because if your data is on GPU but model or CPU or vice versa, then you'll get an error. So both data and model need to be on the same device. Okay, let's do some inference. I'm gonna send a request to my model and predict what is the sentiment and attitude of this piece of text, my random text for evaluation. With this piece of code, I can achieve this. Softmax, it returns probabilities for what is the likelihood the sentiment is positive, or what is the likelihood the attitude is hostile, friendly. So I do this. I got 0. I think 0 is negative. Yes, and here I have sentiment encoder. I do inverse transform, and I can see that this given text has negative sentiment, but it's friendly. At least it's friendly. Okay, I'm done with multitask classification. I'm ready to move to translation example. So no worries. If there are any questions, you'll be able. I'll be able to answer them later with Artem. Translation. Also, I'm trying to do this quite quickly because we have also Artem slides, Artem code. So what I need here is auto tokenizer and auto model for sequence to sequence. Sequence for sequence is actually translation in the world of NLP and language models. What does auto stands for? It stands for I can import any model. So for instance, let's go to MT5 page. We have MT5 for sequence classification. So this, if I import this, it would be the same if I do this auto model for sequence to sequence, and I specify. Okay, it wouldn't be the same. You'll need to do some extra changes, but overall, if I do like this model to from okay, if I run these two pieces of code, I expect to get the same output. However, with this, I could only import MT5 architectures. With this, I could import any available on Hugging Face. So okay, let's go hands-on. For this tutorial, I'm going to use open source available dataset, Opus Books, with translation already available from English to French. So, and for the sake of saving time, because training language model is computationally expensive and fine-tuning as well, I'll just use the first 1,000 records. Actually, you'll see later how they look like. Okay, I'm gonna have this. That's how my data set looks like. I have two columns, one in English and other in French, and I actually have just text translated. So my input is first column in English. My target label or output is the text data in French. You might ask, why I need to fine-tune text translation model if I have Google Translate, DeepL, or other well-known translators. So, for instance, there is a low represented language or specific communication style that Google Translate cannot capture. For instance, we have Crimean language or Latin language, whatever, which are low resource languages. They are low represented, and existing translators do not perform quite well. So then you can train your own transformers model, fine-tune your own transformer model to work well with these languages, and they might outperform Google Translate. Plus, for instance, you need to translate huge amounts of text, but you don't want to pay for Google Translate or DeepL APIs. So in that case, you can just go to Hugging Face or fine-tune your own model, translation model, and use it locally. And do not pay for the API, but just pay for the kilowatt hours consumed on your laptop or local machine. This is the reason why it's still topical to fine-tune translation models. Yeah, I have two separate variables, source text for text in English, target text for text in French. I'm not sure this code will not give me an error, but let's see. Okay, I haven't received any error, looks like. Let's look at model 2. Yeah, it's actually almost the same as this one, but the only difference is in the way we initialize them. So we're going to use just the model from auto tokenize. This is the same as the model 2. Okay, I define here what is the source language, what is the target language, what is the prefix. For MT5, it is required to specify the prefix. What task I'm going to complete? Summarize, translate, classify. Sometimes it is required, especially for text generation. Also define the data set, the same way we did for multitask classification. Okay, and we return input IDs, attention mask, and labels. Here we have just one label. It's just the translated text. Okay, and max length here is going to be also 32, but I could increase it. And that's how my translation data looks like. So all text got decoded and expected labels as well. Yeah, also it's recommended to use data collator for sequence to sequence. Data collator is something that also speeds up the model training and improves performance. You might read more about it in the documentation if you're interested. Evaluation, we will not use accuracy, precision, recall. There is a bunch of metrics called BLUE, and for translation, Stacker BLUE is quite good one, so we'll use it. Some functions to post-process the text, to calculate the BLUE metric. Okay. Yeah, we also need sequence-to-sequence training arguments, sequence-to-sequence trainer. So for classification, we use just training arguments and just a trainer. So let's, okay, actually, we do this again here. It's not necessary at all. And yeah, I define the output directory, learning rate, batch size. If you are low on memory, or especially on GPU or CPU memory, your batch size should be lower. Because if you specify a huge batch size and you have memory constraints, then you are very likely to receive out of memory error. Yeah. Okay, not out of memory actually, but rather that GPU memory is not sufficient. Okay, let's define this, and we're gonna perform the training. It will take some time, and we train it just in 3 epochs, I think. No, just in 2 epochs. Yeah, as you can see, it's gonna be it's gonna take a little bit more, because we deal with sequence to sequence, so we don't just predict 1, 2, 3, or 0, but we generate text and we generate a sequence of numbers and we decode them. Okay, should be ready. What is the BLUE score? Total flaws. I don't see the BLUE score. Anyhow, it doesn't matter. Let's save the model. Okay, model is saved, and now let's perform some inference. Let's do some translation. So this is the path to my model. It's the same I just saved. I specify here eval, which means model is in evaluation mode. Translate, length should be, okay, this is the default one, but yeah, here I specify 32. And translate English to French. Nice to meet you. Okay, Ukrainian text. Oh, I forgot to rename the variable. Yeah, because I played with Ukrainian. So, okay, nice to meet you. Nice devos recounter. Now, good evening. We are from the data storyteller community. Bonjour. Okay, I'm not good at French, but I think the output looks quite valid to me. Let's go to DeepL and ask it to English. Yeah, data history community. I think it's still good. So unfortunately, we cannot translate here from French to English. But I think with some improvements to model architecture and specifying French to English, so it will be then a multitask model, obviously, not a single task like right now, but we'll be able to achieve some good results as well. Okay, I'm done with my code execution. So Artem, please go ahead with LoRA. I think we are very excited to learn about this technique.
Yeah, hello again, everybody. Today I will show you how to fine-tune a bird model for text classification with LoRA, and you will see some interesting features that LoRA allows us to do. First, our initial step is installing all required libraries like datasets for loading data, transformers for loading base model, and tokenizer, PEFT, that is Hugging Face framework for implementing parameter efficient fine-tuning methods, and evaluate for loading metrics and to evaluate our model's predictions. Next step is importing packages and downloading data. I chose IMDb dataset. It is very popular dataset in natural language processing. It is sentimental analysis data that consists of 3 splits: train, test, and unsupervised. Today we will use only train and test split, and each of the split consists of 25,000 rows with text and label. Here you can see how it looks like that here is text of review. Yeah, I saw the question about data records, text records. Here there is a data record, so it can be a few sentences or 5 or 6, yeah, and a label of this review. Also, we need to decode these labels. 0 means negative and 1 means positive. Yeah. Next crucial step for fine-tuning is preprocessing data. For these purposes, you need to firstly to load tokenizer for your model. In my case, it is BERT tokenizer for BERT-based case. Yeah, and then create tokenization function. You should pass here especially text and pass this text to the max length. Now you can observe how it looks like after pre-processing. Yeah, that it has all this feature which Taras also mentioned, and how it looks like here. There is inputs IDs. Next step, I chose 1,000 examples for each split, so we can train our model on 1,000 of train examples and evaluate it on 1,000 of test examples, which model has not seen yet. Yeah, we can observe that our features is here and pre-processed. Also, we require label to ID and ID to label mapping, so we can transform 0 and 1 to negative and positive. Next step is loading the base model and inputting our label mappings. Yeah, we can observe here message that it is not trained, yeah, and it is base checkpoint. Next, we require to configure our LoRa module. Here, how it looks like. We need to specialize which task type you wanted to do with it. It can be mostly every existed task in NLP. Also, we need to specify two crucial parameters. It is R and LoRA alpha. R, it is parameters that determines the rank of dimension of the LoRA matrices, and alpha, it is alpha parameter for LoRA scaling. You can initially interpret it like the measure of how our model will rely on its original weights, frozen weights, or on the new. Yeah. Also, you can specify dropout, which models you want to train and where to inject LoRA matrices. Here it is query and value. Yeah. Also, there is a rule of thumb that you should choose alpha twice bigger than arm. Okay, next step is combine our LoRA model and our base model. Also, you can specify its name here. For this workshop, I called it only LoRA 1. Okay, here we can observe how our LoRA model has changed our amount of trainable parameters. Yeah, so we need to train only 75,000 parameters instead of 110 million parameters, and it is lower than 1% of general amount of trainable parameters. Yeah. So next steps are configuring training process, like training arguments, how we want to evaluate, number of epochs, and batch size, etc. And also we need to compute matrices for evaluations. In this issue, I chose the simplest accuracy. Next, we can train it with trainer and observe that for 10 epochs, at each epoch increase accuracy and lower the validation loss. That means that it has learned quite good. Yeah. Also, we can see that overall train time was about 17 minutes. Yeah, and we have and it is pretty small train time for models like birds. Next, we can also observe how it was injected in our model architecture. Here is query and value blocks of attention blocks. And here is injected LoRA dropout for regularization of our model, and LoRA A and LoRA B. Also, yeah, it adds a classifier wrapper to save it classification head. Next, I saved it, and for demonstration purposes, loaded it from scratch. Here, how it looks like, which we load our base model and specifying the path to our LoRA module and the adapter name. And also, we can inference with it. So we can see that this movie I input. This movie was really bad, and the output was negative. So it has trained right, and it predicted it correct. Also, Hugging Face interface allows us to observe different parameters about our PEFT model. We can see here active adapters, available adapters. Yeah. Also, you can also merge your trained adapter into a base model, but after that, you cannot restore your base model. Yeah, it will be changed permanently. So next, for experimental purposes, let's train another LoRA, but with a little bit higher R and LoRA alpha, and also on another part of dataset. In the previous, I took with seed 42, and now it's with 84 to be sure that we took another 1,000 examples from training and testing data. Now we can add this new configured adapter to our existing PEFT model, and now we can see that we have two available adapters, and our active adapter is adapter number 1. And now we see we can set active adapter our new adapter and see amount of trainable params when we have increased R and LoRA alpha twice, and it has amount of trainable params in similar direction has increased. Yeah, and now our active adapter is adapter number 2. In the same manner, we configuring our training arguments and training process and train our model. It took it took the same time, 17 or 18 minutes, and we can see that with a little bit bigger R and LoRA alpha, we obtain a little bit better results on 0.02 increase in accuracy, yeah, and proportionally decrease in validation loss. So the main feature that we, when we have a few LoRA adapters, that we can use them simultaneously. For example, here we have a batch of 5 inputs. We can specify even our base model to be as a predictor and to use only its weights, and specify another adapters for another inputs like this. So first sentence was its class was predicted by base model, and next 2 sentences were predicted by adapter number 1, and the last 2 sentences were predicted by adapter number 2. So it gives you ability to has a different version of your models that you can change on fly, and you don't need to store any independent fully fine-tuned models, and it is really small. For example, this LoRA adapters size were about 1 and 2 megabytes. So yeah, and it can be used really effectively. And here we can observe our results. You can see that our base model is wrong, but it wasn't trained on this task. So yeah, it is obvious that it should be wrong. And yeah, we can still see our available adapters. Yeah, and save our second adapter. And in conclusion, I can say that PEFT methods like LoRA can give more flexibility in fine-tuning different types of models, especially in an environment with constrained resources. Also, it gives ability to change fine-tuned matrices on fly or use them in the same time. Yeah. So thank you. That's all.
Okay, thank you, Artem. It was a great code session. Yeah, thank you also, Artem, for answering questions we had in the chats on YouTube. And so we actually we are ready, right? Or there is something we are ready to start the Q&A, or there is something more you would like to showcase?
So we had a lot of questions in the chat, so Artem managed to answer all of them, or I should say almost all of them. So guys, we have a few additional minutes, so feel free to ask questions so guys are able to answer them. And by the way, I'm just sending the feedback form that you can fill in, and also don't forget to leave the to press the thank you button for the speaker. So this is very important since guys prepared a lot of stuff to share with you. And welcome to leave some feedback and choose the right number of stars. So any questions?
Okay.
Yeah, so the simple about IT is asking the top questions today. So thank you. By the way,
Yeah.
it looks like I know who it is. So thank you for coming today. Your questions are always very important at all our sessions related to AI, to the garage community as well. Thank you for coming. Yeah,
okay.
sorry, it was a bit fast. So anyway, guys, we spent about an hour and a half talking about a lot of things, answering questions. So such things are usually very exhausting for speakers, spending 1 hour talking, answering questions. So Taras, Artem, thank you for coming today. Thank you for presenting so much stuff. Guys, thank you for asking questions. So all that conversation is very important to improve ourselves, to make conversation, and we are usually doing our sessions once per month. So I guess this summer we'll have some break, but at the end of summer or maybe in September we'll see each other again. So providing more information, running more sessions. So Taras, Artem, maybe you have a few words at the end of the session.
Yeah, if you don't object, I just would like to thanks for having us, and we really put lots of effort to prepare this talk today, and have the code as much explainable to everyone as possible. If there is something we couldn't answer or something was not understandable to you, please go ahead and learn data science AI, and it will get understandable over the time. And feel free to reach out to us. We'll share the code, the notebooks a little bit later. I think we can attach them to the event page, correct, Bogdan?
Yeah, so we're going to attach all that things at the event page, so you can click and get access to all that stuff. So I guess it will be done a few days later after the event. So feel free to reach me in direct if you have any questions, if you have any suggestions. So, and we are going to share all materials that we're going to share all materials that are available and speakers can share.
Okay. Yep. Thank you.
Okay, thank you for your attention. It was really a pleasure to have some good audience. Thank you for questions. Yeah, and reach us out if you have any additional questions.
Yes, and thanks to Daniil, who is working at the backend and doing all that magic. This is very important for us. Thank you. Have a nice day. Be safe and see you soon.